This is a tutorial on gill sectioning for Amanita, or in reality, agarics. And I wanted to use a much smaller fruiting body than I had in my first attempt at a tutorial. And so this is a Satharella, it's small enough to show two techniques that you can use and that I have used in the past to get successful sections. The different things that I will be using throughout the video will be, for first method is Styrofoam. If you have Styrofoam peanuts, that's the best. I don't have any, so I just found something similar enough and kind of retrofitted and made a smaller square of what I'm going to use. So I'm going to end up using pieces like this. If you have an S Styrofoam peanut, you kind of also want to make it into a rectangle. You won't use it in the S shape. So you have the Styrofoam, 80% ethanol. You're going to need oil immersion, something to place the ethanol in to hydrate your sections, and then a needle to guide the sections on the slide, a forceps with a very, very fine tip. I don't recommend using something like this. They're very, very thick. You'll lose your sections on the ridges, and it's just not fine point enough. You'll also need slides for the second method, which is basically kind of using it like a cutting board. And if you have the option of choosing what kind of blades you can use, I recommend using these really thin ones. This one's been cut in half to save the whole thing, but these are the best if you can find them because they're much thinner, so they're much more flexible, and they're much thinner than, say, these guys. So this is good for heavier duty things, for cutting into the fruiting body, especially when they're large, or when you're trying to cut through the base of a fruiting body that has a lot of dirt or something, rocks still attached. This is good. If you're trying to cut your Styrofoam to give it a shape, this is also okay. And the best thing to actually get through your sections is going to be a much smaller blade. So if you haven't had successful sections, it may be the fact that your blade is just not thin enough. And these are regular blades. These are not microtome blades. These are just the kind that you find, I guess, in beauty salons. I guess they're for removing callus from people's feet. But basically, yes, these are absolutely ideal, even though these are more commonplace in stores. So the first method requires you to use Styrofoam. Now this is very porous. This is not ideal. You would like something much more dense, like a Styrofoam peanut. This is all I had. So I'm just going to show you how to do this, but I'm not actually going to follow through with the sectioning because I cannot get good sections with this right now. Because of the fact that this is not ideal, and the fruiting bodies that I have are quite delicate, and I actually would prefer to use my other method, but I'll show you how to get started with this one anyway. So you would grab your Styrofoam. If you have an S, a Styrofoam peanut in those like S shapes, you would still cut this so that it becomes a rectangle, and then you're basically looking for, you want to flatten out the edge because this will be your starting edge, and you're going to cut it open this way, and then it will hold your section inside like so. So let's pretend that this was my gill section that I wanted. You're going to place it in a way where you understand the alignment. So if you can see, these are the gills. You place it inside. Then you would cut, the first cut's a waste because you're just trying to get it flush, the Styrofoam flush with the actual tissue you're looking to cut. So this one usually wastes a lot of the blade, so you don't want to use your best blade on this. And then when it's ready and flush, you can switch to your better blade, something like this, and then you can cut through and it's way better. The reason I'm not going to do that is this is not the right type of Styrofoam, but this is generally the idea. And then what you would do is, if you have your section, you would take your section, usually it's attached to the Styrofoam, you'd place it in alcohol and it would separate, and then you could take your piece out and hydrate it on the slide. I'm not going to do that. I'm just going to go right into method number 2, which is my favorite way of working. Also because you don't have to have styrofoam. And it's with tools that you already have. You're basically going to use two slides. So with this method, now this particular fruiting body is actually quite dry. So every time I press any pressure onto it, and I'll show you what happens. What you would do with this method is you're going to hold down your tissue with another cover slip, and that is kind of a guard, because trying to do the styrofoam method, I usually always end up slicing my own skin off, which fine, but if you don't have to, why not? And so what I usually end up doing is you use this as a guard and as a guide, 2 in 1. However, you should press down first, and this actually may crush the really small gills because they're very dry and it's a small fruiting body. So I'll show you what happens when you don't rehydrate tissue. I'm not a fan of rehydrating tissue. My sections are never that thin on rehydrated tissue, which is pretty much, I think, the opposite of what books tell you. It just doesn't seem to work, and this is after, 15 years trying to do the rehydrating method. But if it's not rehydrated and it's very, very brittle, when you press down to make a section, because you want to hold down your piece, you've just crushed your gills in probably many, many pieces, such as this. So you've kind of just pulverized your section, and that defeats the purpose. So for this second attempt, I have some ethanol in here, and I'm actually just going to grab this guy, plop it in the alcohol, and take it right out. Now this one should be able to sustain pressure from my cover slide, from my glass slide. And again, I want to kind of place it so that I know what's where. It's still kind of toasty, but it's more flexible. It's probably toasty. This is just ethanol. It's 80% ethanol. There's not that much water in this mix, but just want to make sure that I have it. Yeah, so here you can see the orientation of the gills. And I'm going to try and cut anyway that way. So the way this method works is you hold down your piece. The first one is guide, so that you're going to use this edge as a guide to, let me know what the camera sees. Okay, so you're going to use this slide to guide you in the direction that you're going to cut. And like I said, the first one is just the first one. You're not going to use that at all. So now everything's flush, and now we're going to have to start moving the top slide back as we start consuming the actual tissue by making our sections. So we're going to move back. Now for this tutorial, I'm not going to be hunched over my slide the way I normally am, because it defeats the purpose of showing you how to do it, but I usually get really close and with my head practically right on top of it. Okay, so there's already one here. It's huge though, and I know that it is because I can see it. Oops. Stop moving. So I can place it in here, but it's probably too big. And we're going to keep doing this until you do as many as you can. Take your time or go fast, whatever helps you make really thin sections. Now I don't do a sawing method, I just go straight down like you're chopping onions. There's a whole bunch here. I think you can see them. One way to challenge yourself to get smaller sections is just think of it as, how many sections can I get with this little piece that's sticking out from the glass? The more you can get means you're probably getting thinner and thinner and thinner sections. So let's say that I move this lid, the top here. So your challenge is to get as many slices from here until you hit the glass. So can you get 10? And that's one way of thinking. Instead of getting nervous about how many or how thin they are, just try to get really a large number of sections in that little piece. All right, so I've done some. I'm not really happy with any of them, but because I'm kind of doing this quickly for the tutorial, I usually take a really long time to do this. So I can already tell these are huge sections because they're rather thick. So I'm actually going to try to do a little bit more until I'm pleased with what I have. I keep getting out of the camera because I don't know where it's pointing. Okay. The other reason I like this method is because you're not wasting the blade on styrofoam. I mean, sure, you're going onto glass, which will dull your blade anyway eventually, but here's a trick to pick up pieces. You moisten the tip of your needle and you just touch and go. Maybe there's something in here that I like. There's some in here that I like. So let's go right ahead and use this same slide. And here instead what we're gonna do is we're gonna put a droplet of water to rehydrate the piece that we wanted. And now I need to go get water. All right, I got lazy and I put water in a measuring spoon. So what I usually do is the back of the needle, and you're looking for the thinnest pieces. Sometimes it's easier to just use forceps. out of the camera because I have to get really close to see the pieces that I want. Okay. All right, so this should be a little bit more in focus. And what I'm trying to do is to separate these somewhat from each other for when I put the cover slip. They're all arranged in the same way. So put it like this and then place the cover slip. Which I should have. So these should be good enough, but let's just add some more water to the glass slide. Otherwise, with the heat of the microscope, it'll start to dry up and it moves our gills around under the scope. So we're just gonna give it some water. And we don't want to squash down. You can do the squashing method later on. If you notice your sectionings weren't very good, you can always just make a squash mount based off of already something like this, instead of grabbing, let's say, this piece and making a squash mount. That would not be ideal because it's too messy. This one, at least, you have the minimal amount of cells and you can really look at the cell type, Basidia, Basidioles, etc. Chalo, Pleurocystidia. I actually have no idea what Satharella has because I didn't do my homework before I did this, so I'm just going to let it be a surprise and see what we get. So I can't get rid of these air bubbles. You can sort of try to do that. Try to break them up a little bit, but this should be fine. So then let's see what we got under the microscope. All right, so I actually already placed my slide, but let me just show you how to properly use a microscope. So you want to always have it where there's no objective in position, and remember that images in a microscope are inverted and upside down. So if I were to place the slide in a way that made sense to me, in reality, when we look at it via the microscope, instead of the gills facing down, they're all going to be facing upwards. So I'm actually purposely placing it so that it's backwards to me. Well, I should say upside down. And then we're going to look at where I placed it. You can always guide yourself with the light. Let me just see if I can get this to show. So you place your slide, you're going to place your slide where the gills are upside down looking to you. You place it without any objective being in place. You can use the light to guide you as to where you should be. So as you can see, there's that little circle that's right on top of our gill. And now we're actually ready to look at our first objective and see what we've got. Okay, so this is one of the sections that I said is no good. And the reason why I know it's no good is, I mean, I have the top, right? I have the top of the cap. But if you look at the gills, they're fine in the very beginning, but as you start to go down, they've already twisted themselves onto the finer surface, onto the surface with the most area, which is unfortunately the side. So this means that this is way too thick. And also the bottom of the gills have been severed off in my sectionings. So this one's much better. Try to get it in focus. So if we go to the top of the cap, so we're going to say this is the top. I may have removed the topmost. I mean, no, this looks okay. So this is the top of your cap. This is your pilot's context. And then you look at the gills, and the gills are still in the appropriate orientation. I believe not any of them have really twisted. However, whether or not we actually captured the very end, the edge of the gill, is still to be determined. Possibly for, this is maybe, but as you can see, oh, yep, this one twisted. So this gill that's right in the middle, kind of creating a diagonal line. Right now it's in the appropriate position, but as you start to go towards the edge of the gill, it's already been twisting, and then finally we get here and it's twisted, so we no longer get to see the properties we wanted to see. But maybe in the truncated gills, which is what I think this is, this could be a truncated gill. Oh my lord, I'm going backwards. This is a truncated gill. You can see the edges there. This also looks like a truncated gill, also because look at the width. It's much more narrow than these other much longer gills. But basically this is what you want to see. You want to see a hair comb. You want to see basidia to the sides, not facing you but to the sides. So let's get even closer. This gill is very pretty. And you can see the four spores on the basidia. So it's a 4-spored basidia. Let's get even closer. And I'm sorry the video is shaky. I'm having to hold my phone in my hand against the eyepiece, and then with the other hand try to do everything else without really getting out of frame. So it can be a little tiring to watch. But this is pretty nice, and I like that their spores are naturally, because this is just water, but they're pigmented so we can see them from far away. And so this is what you want to get. You want to get sections that are very, very, very thin so that you can see these properties and you can measure different structures. But in order to measure, the best way to do that is to go into oil immersion. So let's look at it with oil immersion. So when you're getting ready for oil immersion, you're usually already on the second to highest objective. This would be your high-powered dry objective if you have all of these. And the last thing you're going to do is go into oil. But in order to do oil, you want to make sure that you don't get oil on anything else and only on your oil immersion objective. Now, one thing that it depends, some microscopes, the transition is very smooth, but if your section is pretty thick, then the cover slip is going to be a little bit high, the actual slide is going to be a little bit high, and you won't be able to transition so well. So I'm going to show you what I typically do. I'll lower down the stage just a little bit, and so you have your oil immersion, and you want very little. You don't need the big drop that comes with it, and you place it over where you want it to be. Now you should be ready to slide your oil immersion objective, and then you can slowly move upward. Now there's a trick that I use that I actually just face the microscope and I look at it and I start to slowly go up until there's a little change in light, and that means that the oil is now touching all surfaces and we are ready to do the fine adjustments with the fine adjustment knob and look at our specimen. So this is our specimen now in oil immersion at highest magnification, and you can see that the structures are much more clear. You can see your basidia, your basidioles. Sometimes you can just, and obviously the spores. You may be able to see sterigmata. And basically these are the sections that allow you to make all the measurements that you'll typically need. With hyphae, it's a little bit harder to look because these are not that rehydrated, not that great. I find that if you have melters, everything rehydrates way better for me personally versus Congo Red and KOH. And one last thing you can do with this section, let's say you're unhappy with it, you can actually take this section when you're done with it and make a squash mount and then look at the same exact structures spread out apart. Alright, so what I like to do with these squash mounts is take a section that I've already made and I've looked at it and done whatever I needed to do with it, but it's still valid. There's still things I can see. And then what I end up using is I end up using the back of a mechanical pencil because it has the right pressure. It doesn't let you go farther than that. And it's a pretty good guide. So this one in particular is tricky because I already put oil. So to remove oil, there are ways around it. Ew. And then what I'll actually do is just place this on top. Now this will help absorb the water that's going to be released out from when I start the pressure. But you want to remember where you had your sections. So they're kind of in this area, so there's no need to be applying any pressure to the corners. And it doesn't matter if it gets oil all over the top because we're still going to be using oil immersion. You can see the water is coming out from the slide. Now this would have flattened out a lot, but it doesn't seem flat enough. So I just keep going. Sometimes you can just hold the glass down until you've basically destroyed what you see. So they're pretty squashed. So I'm going to add oil immersion again and see if we can see any spores and count them and look at the structures, how they would appear under a squash mount after a proper gill section. Okay, so here is my squash mount. It could have been better, it could have been more squashed out, but just to give you an idea, what you end up doing is something a little bit like this. And what we're trying to do is actually see the structures as if they were wide open and split apart from each other. So obviously this did not have enough squashing. I could have squashed a little bit longer. But in any case, there are some areas where you can tell already are going to be useful to look at. Let me just see if it's down here. Focusing. Yeah, this is still very much intact. You still have a sense of that you're looking at gill and that this is a gill, but maybe here is a little better, more destroyed. This could be, it's blurry because this has oil immersion, but I'm on the lowest magnification, so I'm nowhere near the droplet, but it's probably making it a little blurry. So what I'm going to do is I'm actually going to zoom in onto this portion here, because I feel like structures were separated from each other best than anywhere else. And then let's see what we get. Okay, so here is a good part that I found in my sectioning, because it lets you see the structures with the basidia much more clearly without so much difficulty of trying to see between so many cells. And you can distinguish where the base is. You can measure the basidia at this point. You can measure their length, their width, and you can see the structure and the shape a lot more clear. So this is what a squash mount will give you, is this ability to see cells as if they had been dissected or separated from each other, when a gill section isn't going to necessarily give you all of those features that easily. It can, but it requires a lot more repetition and tries, whereas a squash mount will give you at least the basidia and basidials and any other ornamentation on the cell surface, or if there's pleural or calocystidia, you'll probably be able to measure them a lot better. Now, as far as looking at the trauma and such, it's probably best not to do a squash mount because it's completely obliterated any organization that the cells have and the hyphae. So this is best just for looking at these edge cells, and it's also useful for looking at spores. Now, spore measurements, this is not a mature specimen because there's really not that many spores to look at. Usually there's so many you don't know what to do with yourself. But with spore measurements, what we're trying to look for is the adaxial flattening. We're looking for the base, the apex, and trying to make sure that you have a complete view. So luckily the spores in this specimen, they're easy to see because they're pigmented. So as you can see, there's not that many in this mount. I'm going to come back and see if I can find one. See, this one's an interesting one. This is an example of a spore that's not quite ready for measuring. You could try. And obviously in this case you'd have to it's a little hard because it's the same. I'm using the eyepiece that has the micrometer, is the same one that's recording. So obviously you would place it in a way where you can measure the width. This isn't quite aligned perfectly, but the problem with this spore is that the apex and the base are not I don't see them in frame at the same exact time. Like, they're not clear at the exact same time. So let's try to find another one somewhere, maybe even just in the water floating around. Doesn't have to be attached. Ideally it shouldn't be attached. No. How about this one? Let's put it in the middle. And this won't be as difficult for you. It's just very hard to do one hand with the phone, the other hand holding everything else. This one's also not in proper view. Can't measure it. This one, however, now all of this movement is just the water that's dehydrating from the heat. This one looks much more ideal than all the other spores that I found. So what you would do is you locate the adaxial flattening, you take that measurement, and you can see the apiculus in this case is to the top left corner of this spore. The adaxial flattening would be to the bottom left. And so you take your measurement there, then you would rotate to take, let's see if I can rotate this, almost. Nope. This is going to make everyone dizzy, but I don't have an option. And then you would obviously move it so that it's lying over the micrometer. And you would measure the base, not including the apiculus. I usually move the spore until it's up against one of the longer lines, the starting point. It always makes it so much easier. This is just incredibly hard to do because, like I said, the phone is just floating just above the eyepiece so that I can record. So this seems just so much harder than it needs to be, but it shouldn't be that difficult. Well, so I can't really do this right now. So what I would do is I would align the base to the 50, the line that says 50, and then measure and see how many microns I can get. And then you have your length and your width, and then you move randomly in your slide. So you're not necessarily trying to get anywhere in particular. You're just trying to see what you can find, making sure that you're not really going over the same spaces that you've been before, because you don't want to repeat the count of a spore. So here is a gill that I just cut and threw right onto this onto the slide. And as you can see, it was much more mature of a specimen than the first one I tried. And so let's go to oil immersion and see how we can how we can measure these spores and really understand what lateral view means. So what I'm looking for at the spore, now this particular genus, Satharella, has a truncated end. So what is the top part is actually the apex. It's not the bottom of the spore. The adaxial flattening would be here, in this case, to the right side. And the apiculus is that little bump on the bottom right. Let me try to get it away from let me go to where there's no micrometer so we can look at it best. So, okay, so you can see that the top part has the apex has the truncated end. There's this little dot at the very bottom right. That's the apiculus. The right side is going to be our adaxial flattening. So when we measure, the easiest thing is to go parallel to that flattening. So let's go back. Okay, so here where the spore is, what you would do is you would move your micrometer so that it is parallel to the flattening. And then you would move your spore. Keep switching hands. So you would move your spore so that it is in line with your micrometer. And then you can measure. Now obviously when you're doing this yourself, you can do it much more carefully, but this is roughly around 15. It's around 15 microns. Yeah. I would say it's around 15. Then what you would do is you would rotate it. You would rotate your micrometer, and again find the widest part. Now this isn't perfectly aligned. Let me just rotate it a little bit more. Yep. Then we have to kind of get it to go up because it's not at the widest part. And then you could say it's roughly 9 microns. So 15 by 9. Now one of the things that I wanted to do is show you what not to measure. So when you're measuring, let me actually zoom out a little bit, not that much. So one of the things that I did was I actually went away from the slide, the gill piece that I actually placed. Because what I wanted to find was free floating spores. What I did not want to do was go directly where I had, no. Oh, that's probably why. Let's go this way. Maybe it's here. Okay, I think this should be good. Yeah, so what I didn't want was to measure spores that were directly on the surface of the, still attached almost seemingly to the basidia. Mainly due to the fact that you're not going to get them in the right position. It's very, very difficult to see the apiculus because they're probably still joined with the sterigma, and so it's blocking the view of the apiculus. But it's a lot harder to see them in the appropriate view. You think you have them in the right view, but like I said, you're looking for apiculus, base, apex. In this case, apical. The apex is truncated, and you're looking for all these other features. And this is nice to just get an idea of pigmentation. This is a dark spored, brown spored specimen, so this makes perfect sense. And this is just water, but and you can see the colors en masse. But for measuring spores, the best thing to do is to find them free floating, even if that means that they might be moving around, and you have to kind of chase them down. But ideally, they'll be like this. There won't be too much water. There won't be too much Brownian motion. So you'll be able to make your measurements as needed. So that's basically how you would section gills and get spore measurements.